All right, so now we're going to look at translating the graphs of other functions, such as quadratic, cubic, and absolute value. Most of this sheet is going to be about the quadratics, and we're going to see the cubic and absolute value and even some square roots at the very, very end of this one. Okay, so if you watch the notes from section 2.6, you know that when it is an x squared function, meaning, my biggest exponent for x is a 2, it's going to graph a parabola. And this is my parent function. Remember, it looks like this. So the direction of opening, I want to know, is this a U that opens up, or is it one that opens upside down? Well, this one opens up. The horizontal motion from the origin, it does not shift left or right at all. That is neither. And there's a part that I somehow managed to leave off of here, and that is about the vertical motion. Okay, and from the origin, this one does not shift up or down at all, so this one is neither. Also, from watching the 2.6 video, you should have seen that after your squared part, you've got something that comes after it that is going to move it up or down on the graph. So instead of my vertex being at 0, 0, it's going to go up to 3. And then it's going to be the same graph. It's just been moved up on the coordinate plane. So once again, the direction of opening is up. It did not shift left or right from the origin at all, so that's neither. But then your vertical motion, okay, this graph did move up 3. So we're going to add that down here. So now, this one, from the previous video, section 2.6, when it is inside, that is your left and right shift, and you're going to do the opposite. So instead of moving to the left 4 like this might indicate, you're going to do the opposite of that. We're going to move it to the right 4, and it's going to be the same graph. Exact same graph we had in problem 1. It has just been moved right 4 from the origin. So my direction of opening is up. Horizontal motion, I moved to the right 4. And vertical motion, I'm going to abbreviate here, is 0 because it did not move up or down at all. Now, problem number 4 has lots of stuff in it. So we're going to grab our graphing calculator and graph it just as a review, and then we will sketch it on here and talk about the different types of translation or vertical motion, horizontal motion, all of that. All right, y equals negative parenthesis x plus 2, close my parenthesis, squared, minus 3. And then go ahead and graph it. Okay, so this time it flips upside down. Well, what part of that equation makes it flip upside down? Well, that's the fact that this is a negative out in front. When you have a negative in front of your x squared or your parentheses squared, that's going to flip it upside down. My direction of opening is down. So now here's where you can see that the patterns we learned in the linear translation apply here. I'm going to do the opposite of this one, the same as this one. So that gives me negative 2, negative 3. And that is where the graph shifts to, or the vertex of the graph shifts to, but it's the same graph. It is just shifted over and down and flipped upside down. So now my horizontal motion, I went to the left 2, and the vertical motion, I moved down 3. All right, for the next one. Here we go. I had to recopy it over here. So when I've got a 1/2, that is a positive 1/2 out in front. So my direction of opening is going to be up. Then, if you take a look at what's inside, do the opposite. And after that, it's like a +0. So that is going to be your vertex point. So what I'm going to do is move left 1 and up 0. So my horizontal motion is left 1. My vertical motion is neither up or down. Okay, but now all of my others have not had a coefficient in front. It's either been a positive 1 or it's been a negative 1. So remember from the 2.6 video what happens here when it's a 1/2. When that number is between 0 and 1, it's going to make my graph wider. Okay, and these are just sketches. They don't have to be perfect. I need you to recognize what these different numbers added to my parent function, what they do to it, how they affect the graph. All right, and number 6, I have a negative out in front. That negative is going to make this open down. Let's go ahead and get our ordered pair out of here. The opposite and the same is going to make it 2, 4. So my horizontal motion, I'm going to move to the right 2, and my vertical motion is going to be up 4. So right 2 and up 4. I know it is opening down, but what does that 3 do? And I'm not looking at the negative, I'm looking at the number itself. Your book will tell you it's the absolute value of the number in front. Okay? I choose to say just ignore the negative. The negative tells you direction. After that, you don't need to worry about it. The 3 makes my graph skinnier. So same basic shape. It has just been shifted right and up, flipped upside down, and it is skinnier. So now, all of the patterns we just looked at for the linear functions and for these quadratic functions, we're going to follow those exact same patterns when I graph these. There's going to be, a difference in the shape, but all of the shifts, all of the reflections or flips, the stretched or compressed parts, that's the tall and skinny, or the very wide ones, all of those things are still going to happen to these the exact same way. So when you have a cubic function, an x cubed, here's the way it looks. It's going to go up on the right hand side and it's curving down on the left hand side. Okay, if that is a negative x cubed, these two things are going the opposite direction. For an x, square root of x, it looks like this. I say it kind of looks like an eyebrow. Not exactly, but if I say the graph's an eyebrow, hopefully it will help you picture this graph. Okay, x cubed I call a squiggle. This one I say it looks like an eyebrow. And for the absolute value, it is a V shape. And when we get to section 2.8, we're going to be much more specific about how we graph the absolute value. They are always going to be a little bit more than just a sketch. Okay, these and the quadratics sketches are fine. For the linear and the absolute value, we're going to be a little bit more specific with them. All right, so that is the end of the translation videos.